Welcome to part 3 of section 1.6. We're going to be talking about step functions today. Now, a step function is also called a greatest integer function. So now we have a special symbol, and for some reason it didn't show up on this screen in all the places, so it looks like a double bracket almost. So we're looking at the greatest integer less than or equal to whatever x is. So the greatest integer, for example, less than or equal to -1 is -1 because it's equal to -1. The greatest integer less than or equal to -1/2 is -1. If we think about the number line, so we have a 0, a 1, a 2, a -1. So if we're here at -1/2, the greatest integer that's less than or equal to that, so it's not going to go to 0, so it's going to go to a -1. When we're at 1/10, the greatest integer less than or equal to 1/10 is 0. And when we're at 2.5, the greatest integer less than or equal to 2.5, so here we're at 2.5. The greatest integer less than or equal to that, we're going to go to the 2. So those are the greatest integers. So really what we have here is if we're anywhere in between 0 and 1. We put a 0 there, open dot. Open dot at 2, close dot at 1. Open dot at 3, close dot at 0. And you might be seeing why they call these step functions, because they look like steps. Goes down here as well. And you can just kind of pick some values to see where these steps are coming from. I'm not going to draw all of it, but there's our step function. Now for our domain, we can use any value for x we want to, -infinity to infinity. For the range, it's all integers. Remember, an integer is a whole number. There's no decimals, there's no fractions, so we're including a 0 as an output, a 1 as an output, a -1, and so forth, but they're all whole numbers. So our intercepts, our x-intercept is at 0, 0, and our y-intercept is there as well because that's where a closed dot is. Even and odd, there's no symmetry, so there's none. And now it's increasing and decreasing. It's actually constant between consecutive integers. Now we can draw another one. So what we're going to do is we're going to evaluate a couple points, and that's going to give us our first step. And after that, we can just draw the steps from there. So it's the greatest integer. Sorry, the brackets didn't show up on this. The greatest integer of x plus 1. So the greatest integer less than or equal to. So now when x is -1, so f of -1, the greatest integer less than or equal to -1 plus 1. So that's going to be -1 plus 1. So f of -1 is 0. F of 2, greatest integer less than or equal to 2 plus 1. Greatest integer less than or equal to 2 is 2 plus 1, so it's 3. For 1.5, f of 1.5, greatest integer less than or equal to 1.5 plus 1. So less than or equal to 1.5 is 1 plus 1, so f of 1.5 is 2. So we can think about it. -1 our output is 0. So what's going to happen here? We're going to go at 0, we're going to put an open dot. Then at 1, we're going to put a solid dot going over to there. We have an open dot, and you can kind of just draw your steps from there. I'm not super concerned about graphing step functions. As soon as you find the first step, everything else just kind of follows along with that for the most part. Notice the solid dot is on the left-hand side because that's the or equal to portion. And that's good enough as an example. Now we can spend some time evaluating these. So I think that's where it's interesting to think about the values. So let's go to the next page and let's just do some evaluating. We're not going to do any more graphing of these. This is not a major part of our course. So we're going to evaluate, once again, the greatest integer function. Now it's of x plus 2. So it's f of negative 3 halves. The greatest integer function of negative 3 halves plus 2. Working with some fractions here. Greatest integer, negative 3 halves. And 2 over 1 is the same as 4 over 2. So it's plus 4 halves. So it's the greatest integer of positive 1 half. So the greatest integer less than or equal to 1 half is 0. So f of negative 3 halves is 0. F of 1. Greatest integer of 1 plus 2. That's the greatest integer function of 3. Greatest integer less than or equal to 3 is 3. So f of 1 is 3. F of negative 5 halves. The greatest integer less than or equal to negative 5 halves, so it's negative 5 halves plus 2. Negative 5 halves. 2 over 1 is the same as 4 over 2. So we add those fractions, we get a negative 1 half. And the greatest integer less than or equal to negative 1 half is negative 1. Okay, so we'll go to the next problem. Now it's 7 times the greatest integer of x plus 4. The greatest integer is around the x plus 4 only. So f of 1/8, negative 7 times the greatest integer, 1/8 plus 4. Working with those fractions still. So it's negative 7 times. Add up the fractions, 1/8 plus. Now 4 over 1 is the same as 32 over 8. So it's negative 7 times the greatest integer of 33/8. Now for these, I think it's helpful to think about it as a mixed number. 8 goes into 33 4 times, and then we're left over with a 1/8. So it's negative 7 times the greatest integer less than or equal to 4 and 1/8, and that would be a 4. So negative 7 times 4 is negative 28. So that's f of 1/8 is a negative 28. F of 9. Negative 7, greatest integer of 9 plus 4. So it's negative 7, the greatest integer less than or equal to 13. Negative 7 times 13 is negative 91. F of negative 1, negative 7, greatest integer of negative 1 plus 4. Negative 7, greatest integer of 3. Greatest integer less than or equal to 3 is just positive 3, so it's negative 7 times 3. So it's negative 21 for f of negative 1. And then we'll finish off this section with a fraction. So f of 3 halves, negative 7 times the greatest integer of 3 halves plus 4. negative 7, and it's going to be 3 halves plus 4 over 1, which is 8 over 2. Negative 7 times greatest integer of 11 halves. And 11 halves is 5 1/2. So it's negative 7 times. And the greatest integer, less than or equal to 5 1/2, is 5. So it's negative 7 times 5. So it's negative 35. That's f of 3 halves. And that is a step function in the greatest integer. Okay, thank you, and I'll see you in the next section.